This last guy is really, really interesting. So we've got the improper integral from negative infinity to infinity of dx over 1 plus x squared. So what we're going to do is we're going to separate that out. I'm going to fill up all this space right here. We're going to take that guy and rewrite him as negative infinity to 0, because we can pick, of dx over 1 plus x squared, plus 0 to infinity of dx over 1 plus x squared. And what happens is we're going to sort through two different limits now, because we've got one limit for each. So the limit as b approaches negative infinity of the integral from b to 0 and the limit as a approaches positive infinity from 0 to infinity of dx. 0 to 0 to a of dx over 1 plus x squared. So this is what we're working with. Now, the 1 plus x squared part is a tricky wicket, and we have to pay attention to that because this actually fits a pattern for one of the inverse trig functions, which would be the inverse tan. So when we take the next step with these guys, what we're going to have is the limit as b goes to negative infinity of inverse tan. And if you don't remember, look on your trig sheet, look on a trig card, look on a derivative or integral table. This is actually going to be the arctan from b to 0 plus the limit as a goes to infinity of the arctan from 0 to a. And let's get x in both of those. So now we have to sort that part out, which can be a little challenging. So we'll take it one spot at a time. Let's look at the very first guy. The arctan of x evaluated from b to a. So that's going to be stop minus start. So we're looking at the limit then of the arctan of a minus the arctan, that a should be 0. Whoops, 0 here and 0 here. Okay, the arctan of 0 minus the arctan of b. All right, so when we sort all this out, the question is what angle will give us a tangent of 0? And that's going to be pi over 2. Okay, what angle then, what do we approach as x goes really, really, really large towards positive infinity? I need to back this up. This is going to be 0. The angle gives us 0 here. And then when you look at the graph of the arctan, as you grow towards infinity, you actually approach, but don't ever touch pi over 2. Okay? So remember, the arctan looks like, if this is our graph, the arctan looks something like this. And we've got a lower asymptote bound and an upper asymptote bound. And that happens to be at pi over 2. Remember, we're undefined at pi over 2 for the tangent. But we approach pi over 2 as the limit gets really, really, really big. Okay? Let's look at the arctan then from 0 to a. And so, again, the arctan of 0 is going to be, or the arctan of a would be here, and then minus the arctan of 0. So we're going to end up again with pi over 2 minus 0. Okay, so it's for the same reasons, because as you approach positive infinity with the arctangent, you approach pi over 2. So what are we doing? We're adding these two guys together right here. We're going to add this guy right here and this guy right here. And gee whiz, I must not have slept well last night. This needs to approach negative infinity. This first one. So this should be negative infinity here, which would be negative pi over 2. So minus negative pi over 2. There we go. We're good to go now. Now add these two guys up. So when I look at this limit, I'm going to have negative pi over 2 plus pi over 2. And pi over 2 plus pi over 2 is pi. So this guy looks horrible, but when you go through and sort it out and look at it a little bit at a time, make sure you got all your minus signs in there. It actually takes care of itself, and it becomes a problem that we can do. Remember, when you're working with arctan, ask yourself what angle will give you this tangent? Not that tangent. What angle will give you this tangent right here? What angle will give you this tangent right here? Okay? What angle will give you a tangent? What will you approach? What will you approach as you get really large? What are you approaching over here as you get really large? What are you approaching as you get really small? And so when you look at those things, that will help you. And if you can graph this while you're working on it, that'll help a lot as well.